Finding a specified term of an arithmetic sequence given the first terms. Here are two examples. Let's call the first example A, and call the second example B. And I'm going to show you something that's a little bit different from what you would actually see in a textbook. I'm going to show you a method that I teach to my calculus students. So what I'm going to do here is I'm going to visualize an arithmetic sequence in a very similar fashion to a straight line. So if the y-intercept here, let's say it's what, 0, 4. And if you look at the arithmetic difference, since the rise over run, if you look at the slope, sometimes we say rise over run. I don't really like that. I usually like up or down over left or right. In this case, our arithmetic difference is actually going to go up 6, and then we're going to go right 1. So if we go up 6, right 1, and then you go right 1 unit this way. And I could put another dot there, right? And if I went right 1, that means this unit here is 1. And this is the n-axis. So here's a straight line. But remember, in a sequence, we don't have a continuous straight line. In fact, what we're going to do now is I want to transform this ordered pair 0, 4 1 unit to the right. I would love this dot right here. And then for n equals 2, what should I get? Well, I should get the next dot over. So in this case, this ordered pair was 10 units high. This ordered pair, this is not the scale, by the way. This ordered pair is now 10 units high. I want to move this one over as well. And then with a sequence, all you have is actually these little red dots, right? And so on and so forth. So we're going to transform, let's say, this line here, that is a straight line. I'm going to transform it and move just these dots to the right. And how do I do that? Well, it's not too difficult. So let's call our sequence a sub n. We first have to find our slope, or in this case, the arithmetic difference. So the difference here is a sub 2 minus a sub 1, which is 6, which I already drew in the picture. First thing you need is the slope, 6. And then now I need to transform the x values 1 unit to the right. Well, in this case, it's the n values. How do I transform n values 1 unit to the right? I write parentheses n minus 1. Just like you did with your other basic graphs of like x squared or the natural log or the rational functions or the square root functions. If you wanted to transform the n units to the right, you would simply write the quantity n minus 1. You could also think about your conics too, right? When you try to label your center of your conics, you often had a transformation in there as well. Only thing left to do now is to indicate what would have been the y-intercept. So I want to start this at 4. So I'm going to add a 4 here. Add 4. And now we just got to state the domain. For what? N equals 1, 2, 3, ... Even though that is not my final answer, it's very, very important that I show that piece of evidence. This is now what? 6n minus 6 plus 4, so it's 6n minus 2. Once again, write the domain for n equals 1, 2, 3, dot, dot, dot. I'm going to circle this, even though I'm not done, because I'm going to need this. Notice 80 is in the domain, and so we're going to find a sub 80. A sub 80 is going to be 6 times 80, which is 480 minus 2. So that's 478. Therefore, the expression that you're looking for, a sub 80, got simplified to 478. I'm going to go ahead and circle this work as well, and of course the last line includes the final answer. Go ahead and try this technique with part B. You could pause the video right now and give it a try, and then if you need to check your answer, go ahead and hit the play and play the video. This is going to be b sub 1, b sub 2, b sub 3. Once again, let's find the arithmetic difference, which will also represent the slope of a linear line. In this case, 26 minus 17, we get 9. Let's call this b sub n. We're going to write the slope, 9. We're going to transform the n values 1 unit to the right. So I'm going to write n minus 1. And then we need the y-intercept. So the y-intercept is going to be, well, it would have been the y-intercept, but we transformed the y-intercept as well 1 unit to the right. So it will be 17 here. And there you go. Remember to write the domain for n equals 1, 2, 3, 4, dot, dot, dot. 3 dots. Make sure you write the 3 dots. Now, let's simplify this. This is 9n minus 9 plus 17. Minus 9 plus 17, so 8 plus 8. It'd be nice if you check n equals 3 just to make sure it is 35. I'll let you guys check it. I already checked it, it is. We want to find the 51st term, so let's find b sub 51. Let's simplify this expression, which is 9 times 51. That's 450 add 9, so that's 459 plus 8. 459 plus 8 is what? 467. Yeah, that's right. So therefore, your expression b sub 51 is equal to 467. Make sure you show your work. Even though this is your final answer, it's best to show all the evidence that's involved. So I'm going to circle the whole thing. Boop. Same thing up here. I really should have circled the whole thing. Find the 15th term of an arithmetic sequence whose common difference is d equals negative 6 and whose first term is a1 equals 20. I guess the first thing you could do is write the general formula for the arithmetic sequence. A sub n is equal to d times what? N minus 1 plus a sub 1. It really looks like a linear equation. I do need to specify the domain for n equals 1, 2, 3, dot, dot, dot. And then we simply find this formula now. Let's see here. A sub n is equal to negative 6 times n minus 1 plus 20. And once again, for the domain, let's simplify this. A sub n is now equal to negative 6n plus, let's see here, plus 6 plus 20, so plus 26. Once again, for the domain, make sure you write the domain. This is not a continuous function. So if you were to graph this, you would just graph a bunch of dots that has a certain height for the y-axis. But you don't connect the dots, okay? So when you're plotting sequences, you're really just plotting a lot of ordered pairs that are unconnected. We do need to find the 15th term. So a sub 15. We need to find this expression. It's negative 6 times 15. That should be negative 90. It is. It's negative 90 plus 26. So negative 90 plus 26 is negative 64. Yeah. Okay, therefore, a sub 15 is equal to negative 64. There's your final expression. Even though this is the final answer, I'm going to go ahead and circle all the work. The work is needed. Go ahead and try example B. You might want to write B sub n though. So write the general formula. B sub n is equal to D times n minus 1 plus B sub 1. And always indicate the domain for n equals 1, 2, dot, dot, dot. Go ahead and substitute. And simplify your function. State your domain. And let's find your expression. Let's find b sub 22. In this case, it's 88 minus 19. Oh, yeah. 88 minus 19. How much is that? Why don't you take 88 minus 20, which is 68, and then add 1, so 69. All right. Therefore, b sub 22 is equal to 69. So even though this is the final answer, go ahead and circle all your work as well. Finding a specified term of an arithmetic sequence given two terms of a sequence. For a given arithmetic sequence, the first term, a sub 1, is equal to 38, and the 83rd term, a sub 83, is equal to negative 208. Find the value of the 31st term, a sub 31. First thing you probably want to do is write the general formula for the arithmetic difference. The arithmetic sequence. And we know that for n equals 83, we get 208. So the output is negative 288 when n is actually 83. We already know what a sub 1 is. It's 38. So here we have an equation, and all you have to do is solve for d. Let's go ahead and simplify that. Is equal to d times 82 equals 82 is not 0, so divide the entire sides by 82, and we get d is equal to negative 3. Wait, that is not negative 3. I take that back. Let's check that again. Oh, wait a second. I was right the first time. D is equal to negative 3. D is equal to negative 3. Now we go back to this first equation, and we're going to write the function. We're going to write a sub n is equal to negative 3 times n minus 1 plus 38. Let's go ahead and simplify this. A sub n is equal to negative 3n plus 41. And why don't we find the 31st term? So let's find the expression a sub 31. It's equal to negative 3 times 31. That's negative 93 plus 41. So 93 subtract 41, let's see, 52. So a sub 31 is equal to negative 52. There's the final answer, but be able to show all your work. Write an explicit rule for an arithmetic sequence. An arithmetic sequence is given below. Negative 9, negative 4, 1, and 6, and 3 dots. Dot, dot, dot. The 3 dots mean the sequence continues on forever, 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 forever. Now, you know that you're given the first term, a sub 1, the second term, a sub 2, and the third term, a sub 3, and so on and so forth. A sub 4 is in fact 6. Let's write the general form of an arithmetic sequence. I use D, and then we use n minus 1, and then plus the very, very first term. Now, how do we get D? There's many ways. You just take 2 consecutive terms and take the difference. So we're going to take a sub 2 minus a sub 1. The order does matter. You have to do a sub 2 first. So negative 4 subtract negative 9, excuse me. Subtract negative 9 means add 9, so we get 5. A sub n is now equal to 5 times n minus 1 minus 9. And let's simplify this function. I apologize. I should have stated the domain. Domain's very important. And we have 5n, subtract 5, subtract 9, subtract 14. Once again, the domain for n equals 1, 2, dot, dot, dot. That's a 14. Now that's it. We just need to find the explicit formula. There it is. There's your equation, and there's your function. We say a sub n is a function because you could write it like this, f of n, where your input are n values for n equals 1, 2, dot, dot, dot. 3 dots. Well, the arithmetic difference here is 3. You could see that because you could take the 2 consecutive terms there, go negative 1 and subtract negative 4, and you realize you get 3. And we know the general formula for the arithmetic sequence is going to be d times n minus 1 plus a sub 1. We want to find the letter n. Well, why don't we use 437? We want to find the nth term for the value 437. D is 3, and then n minus 1, and then plus a negative 4, which is subtract 4. So here we just solve for n, and then we'll be on our way. Add 7 to both sides, so 4, 4, 4 is equal to 3n. That is divisible by 3. $148. So n is actually 148. So there's actually 148 terms. Now we're ready to find S sub n. S sub n is equal to 148 terms. A sub 1 is negative 4. And then plus a sub n, which is 437, and then divided by 2. And of course, you could simplify that. That's 74 times what? Times 433. Yeah, 433. And go ahead and use your calculator for that. The sum S sub n is equal to 32,042. You could do part B in a similar manner. The key here is to write out the first few terms. Why don't we write the first few terms out? For j equals 1, we get 3. Plus, for j equals 2, we get 8 minus 1, which is 7. And then for j equals, let's say 3, we get 12 minus 1, which is 11. So you can see the arithmetic difference is 4. Now, we want to know how many terms there are. There's actually 95 terms. It's given to us. Let's find the value of the last term. What's 95 times 4? And then subtract 1. So it's going to be 379. There we go. We also could use the formula here. Capital S sub n is equal to, well, in this case, I just realized I made a mistake. Go back to the previous example here. You want to write S sub 148. I apologize there. Made a notational error. Let's go back and fix that. The first example, I want to write S sub 148. Okay, back to example B. We have n times a sub 1 plus a sub n divided by 2. So it's the number of terms times the sum of the first and last term and then divide by 2. What are we looking for? We're looking for S sub 95. We want this expression here. So that'll be 95. A sub 1 is 3, so 3 plus 379, and of course, divide by 2. You can go ahead and use a calculator for this. S sub 95 is equal to 18,145. I could circle the final expression. The first three terms of a geometric sequence are as follows. First term is negative 5, second term is 20, the third term is negative 80. Find the next two terms of this sequence give exact values. The thing you want to do for a geometric sequence is find the common ratio. Once you find the common ratio, you get a much better idea of how to get to the next term. So the common ratio is simply the division of two successive terms. The order matters. A sub 2 must be in the numerator, and then a sub 1 is in the denominator. In our case, we got 20 over negative 5, which is negative 4. So to get to the next term, we simply take a sub 4 is going to equal what? It's going to be equal to negative 4 times a sub 3. And then, of course, a sub 5 is going to equal what? Negative 4 times negative 4 times a sub 3. So you just simply multiply by negative 4 each time to get to the next term. What would a sub 4 have to be then? A sub 4 would have to be 320 positive. And then a sub 5 would be what? Let's take 320 and multiply by 4. It would be negative 1,280. Go ahead and circle those. In a similar fashion here, we want to find a common ratio for part B. So a sub 2 over a sub 1. Negative 64 over negative 256. Notice it's got to be the same as what? Negative 16 over negative 64, which in this case, it is 1/4. So the common ratio is 1/4. Yeah, so how do we get to the next term? So a sub 4 has got to be 1/4 times a sub 3. And what do we get? We get negative 4. A sub 5 then would be what? 1/4 times a sub 4, which is 1/4 times negative 4, which is negative 1. Aha! Therefore, a sub 4 is negative 4, and a sub 5 is negative 1. Let's find the 13th term of the following geometric sequence. Now, we're not going to write all 13 terms here. What we're going to do instead is to find a common ratio. So let's label a sub 1 and a sub 2. And you could even label a sub 3. And of course, this keeps going. If you look at the common ratio, let's just take a sub 3 over a sub 2. We get 63 over 21, which is 3. Now, what is the formula for a geometric sequence? It's a sub n is equal to a sub 1 times r to the n minus 1 for a certain domain. N equals 1, 2, 3, and so on and so forth. But you know what a sub 1 is? It's 7. So a sub n is equal to 7 times what? Times r. Well, what's r? Let's write r in parentheses. So we got a 7. R is now in parentheses 3 to the n minus 1. And make sure you write the domain for n equals 1, 2, 3 dots. Ah, gorgeous. Very, very nice. So let's find the 13th term. We're trying to find the expression a sub 13, which is equal to 7 base 3 raised to the 12th power. And of course, you can use your calculator for this. Therefore, a sub 13 is what? A sub 13 is 372,087. That's 3,720,087. Let's compute each sum below. We have two sums here. They're actually what we call partial sums of a geometric sequence. We say partial sums because it's actually a finite number of terms. There's actually 8 terms here in this partial sum, excuse me. We do have a formula for the partial sum of a geometric sequence. It's s sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. You could easily spot the r here. The r here is 1/3. You could look at it as 2 consecutive terms. 5 times 1/3 over what? 5. So we can see that r is 1/3 in this case. We even know a sub 1. A sub 1 is 5. It's right there. I could point it out for you. It's a sub 1 right there. This right here is a sub 2. And to get the common ratio, you simply take a sub 2 divided by a sub 1. And that's how we got 1/3. The rest is just plug into a formula, but you do need to count the number of terms. So you're trying to find the partial sum for s sub 8. All right, a sub 1 is 5. And then 1 minus 1/3 raised to the 8. And then 1 minus 1/3 here is 2/3. S sub 8 is equal to, let's see here. We could say 15 halves times 1, let's use a bracket. 1 minus 1/3 raised to the 8th. Go ahead and use your calculator. Excuse me, you're not supposed to use a calculator. It says to write our answer as a fraction. So why don't we go ahead and simplify this. Take this expression, s sub 8, and we're going to try to do our best to write fractions here. Let's see here. Common denominator, 6, 5, 6, 1 over 6, 5, 6, 1 minus 1 over what? 6, 5, 6, 1. There we go. So we have 6, 5, 60. 6, 5, 60 over 6, 5, 6, 1. And of course we could reduce some common factors here. There's a 3 in 15 and there's a 3 in 6, 5, 6, 1. So we could reduce a factor here of 3 and 6, 5, 6, 1 is divisible by 3. We get 2187 here. And of course 6, 5, 60 is divisible by 2. We get a 1 here. And we get a 3280. So you're just taking, reducing, I should say. You're reducing common factors. Well, now we're left with 5 times 3280 over what? 2187. Let's see if that reduces any more. I don't think so. And we get a partial sum of 16400, all divided by 2187.